All right. Good morning. 10 a.m. Week 1, day 3, right. Hey? Good morning. 10 a.m. How's boot camp going so far? Week 1, day 3, right. Hey? Good? 10 a.m. How's boot Any camp rough going spots? So far? Has everything been easier, harder than you were expecting? Any rough spots? Has everything been easier, in a good way than you were expecting? Okay. Any rough spots? Awesome. I'm always reminded of, you know, the P90X guy, Tony Horton. You remember? The P90X. He used to say, you should be working out to the point where you really feel it, where your muscles ache the next day. But he's like, you should be working out aching, pain, good, missed the trampoline on the way down, he's like, bad. You know, if your body feels like that, so if you start to feel like you're getting overwhelmed, reach out, ask for assistance, talk to one of the full-timers, talk to Davey, talk to myself, ask for assistance, because it's a marathon, and you're in week 1 of 12, because it's a marathon, and you're in week 1. You got a long road ahead of yourself, so if you need any kind of assistance, any kind of help, a shoulder to lean on, somebody to talk to, if you need any kind of reach out to one of us, okay? A shoulder to lean on, somebody to talk to. Cool. So, quick introduction, because I didn't do my quirky fact on Monday. I think I helped some of you on Monday, though. My name's Andy. I'm an alumni of Lighthouse. Not too long ago, I was right where you are. I work as a full-stack developer in the fintech industry. We're a cryptocurrency stock exchange, but don't ask me about crypto. I don't have any insights. I can't tell you whether to buy or sell. Don't ask me about crypto. For the last 8 months, I've been a mentor here, and for the last 6 months, I've been lecturing. For the last 8 months, I've been a mentor here. Quirky fact: I get overly excited about, seemingly inconsequential things. For instance, I have a favorite operator. Seemingly inconsequential. I don't know if any of you have a favorite operator, and no, it's not smooth. Seemingly inconsequential. I don't know if any of you have a favorite operator, and no, it's not. It is the modulus operator. I don't know if any of you if you've come across it yet. It is the modulus If you haven't, we can talk about it later. That's my absolute favorite operator, followed by the ternary operator. If you've come across that, that's my absolute favorite operator. Hopefully, some of my insanity will rub off on you, and you too will have a favorite operator. Hopefully, some of my insanity. If I accomplish nothing else today, I just want you to select a favorite operator. All right. So let's get some stuff out of the way. Since this is my first lecture with you, I want to talk about the way that I lecture, and I also want to talk about lectures at Lighthouse. You probably talked about kind of overview with Nima yesterday about the fact that lectures aren't kind of lectures in the traditional sense of like a university. Somebody gets up, stands at a podium, and bores you to death for 2 hours. We want to phrase this as more of a conversation. Okay, this is not a time for you to be taking notes or trying to copy whatever I put on the screen. This is a time for you to be interacting with me and asking, what is that you just put on the screen? I don't fully understand that. Can we talk about that? I have a question about this, or I have a question about that. I don't fully understand that. Can we talk about that? I much prefer to respond to questions. I've actually noticed when I watch my lectures back, we record them all. When I watch my lectures back, my tone of voice actually changes when I'm directly interacting with one of you or all of you, rather than just standing up here and droning on all day. Okay? So it makes it more fun for me. It makes it more interesting for you. If you find yourself starting to lose focus, ask a question. Just put your hand up and just ask a question. Starting to lose focus. The other thing is, don't let your fear of other people thinking that, oh, they don't know, so they're asking this question. They don't fully understand, so they're asking. If you're thinking other people are thinking that, they're not. They're thinking the same thing you are. What did Andy just do? What did Nima just do? What did Travis just do? The same thing you are. So ask the question, because you'll be the hero for other people who are sitting there hoping that someone's going to ask that question, but not yet brave enough to put their hands up. The other thing, although you all started as strangers, you're going to probably make lifelong friends here. These are your cohort mates. You're going to get really close. You're going to see these people almost every single day for the next 12 weeks. You're going to work together on projects. You're going to suffer together. You're going to be elated together. You're going to work together on projects. no one really knows what you're going through, like the people in your cohort. Really knows what you're going through. Like I show up and I say, you know, I used to spend 12 hours a day here. I used to be a student, and then I knock off at 5 and I say, see you later. Spend 12 hours a day here. I used to be a student, and then I knock off at 5 and I say, these are your cohort mates. These are your teammates. Okay, so feel free to reach out, talk to your peers. Okay, if you're stuck on something, talk to the people at your table. Reach out, say, hey, has anybody hit this portion yet? How did you solve this? What did you do? We're not looking for copying the code. How did you solve this? What did you do? Talking to your peers is a very real aspect of coding. Okay, it's a very real aspect of being a programmer. When I was going through the boot camp, the number one question that I had was, what's it like to be an actual dev? You know, I've worked in a bunch of different industries. Before I came to boot camp, I was in logistics. I was a warehouse manager. You know, I've worked in a bunch of different industries. And now I program all day. So completely different fields. So I had a lot of questions about, like, what is day-to-day like? And a lot of what you're going to do day-to-day is problem solving, you know, Googling for answers, reading documentation, trying to figure stuff out. But it's also going to be talking to your peers. Okay? And this can be hard to wrap your mind around if you've been, if you've done a bunch of self-study, if you've done Linda, or, which is now, I guess, LinkedIn training, Udemy, watched YouTube videos, stuff like that. The whole time you've been writing your own code. You've been the only one touching it, you're the only one seeing it, you're the only one who cares about it. But very quickly, very soon, in the not too distant future, you're going to be a member of a team. And you're going to all be working together on the same code base, touching all the same lines of code. And who are you going to go to for help but your teammates? You're going to say, hey, I can't, is your server not starting? Did you have trouble with this yesterday? Oh, that's how you solved it. Okay, perfect. And then you're past that roadblock. Did you have trouble with this yesterday? Oh, that's how you solved it. Okay, perfect. But also, don't hesitate to hit that request for assistance button. That's why we're here. All of the mentors would rather be helping students than chatting with the other mentors. As much as I love chatting with the mentors, I'm here because I love programming and because I feel that we are changing lives here, and I want to help you change your life. Okay? So I would much rather talk to you than one of the other mentors that we have on staff. Okay? So I would much rather talk to you than what else? One of the other mentors that we have on staff. Ask for assistance, ask questions during lecture. I will tend to pose a lot of questions. My particular lecture style is I like to start with some to-dos, so we have an idea of where the conversation is going to go, and also to keep myself on track. If I get a question or I start thinking of something and it's too far afield from what we're working on, then we'll just shelve it for later. Okay, but feel free to ask any question that comes up. If I can answer it in the scope of the lecture, or any lecturer can answer it in the scope of the lecture, they will. Otherwise, they'll say, you know, that's a question for later. We'll talk about it after the lecture ends. Otherwise, they'll say, okay. But feel free, anytime, raise your hand. Even like thumbs up are great. I'll ask things like, how's the font size for the people in the back? Even like thumbs up are things like that. This is also your lecture. If you can't see the screen, ask the lecturer to increase the font size or move closer. If you can't see the screen, always asking questions. If you don't understand something, ask a question. That's the number one thing. Always asking questions. Cool. And I guess the next thing that we should talk about is the big one. Asking questions. Cool. And I guess the next thing. Imposter syndrome. Did you talk with Nima yesterday about imposter syndrome? Okay. It is a very real thing. It happens to everyone. Everyone is going to feel like they don't deserve where they're at. They're not as good as they think they are. It happens to every single person. They're not as good as they think they are. Okay. Before lecture every day, I have this big like, and then once we fall into the code, then I'm a lot better. But I still get the who am I to lecture to these people? Right? So it can affect everybody. Like I said, if you feel it affecting you and you want to talk to someone, it can affect hit request for assistance, reach out to one of the admins. And you want to talk to someone, it can affect every request for assistance, reach out to any questions before we start about what you've done so far this week? Did anything come up? Any questions from yesterday or today? Or earlier today, yesterday, Monday? No? Any questions from yesterday or today? Or earlier today? Shake of the head. Monday. Cool. Thank you very much. Thumbs up. Shake of the head. Awesome. Okay, cool. So let us start with a quick review of primitive types in JavaScript. Let us start with a quick review of primitive types in JavaScript to get going. So in JavaScript we have 6/7 primitive types. Can anybody tell me what JavaScript we have 6/7 any of those types are? Primitive types. Can anybody tell me what? Sorry? Any of those string is good. Perfect. Primitive types. Can anybody tell me what? Sorry? Int? Like a number. Perfect. Yeah. There is also a big int, but it's very seldom used. Yeah. Okay. What else do we have? Big int, but it's Boolean. One of my favorite. Okay. True false. What else do we have? Big int, but it's what else? One of my favorite. Okay. True false. We have an object. So if we're saying what do we have access to, but an object is not considered a primitive type, and we'll talk about that. What do we have access to, but an object is not considered a primitive type. Float is a version of a number. Are you coming from another programming language? Float yeah, where they differentiate everything in JavaScript is actually a floating point number. Yeah, where they differentiate just so if you're interested. But we have three more that we need to fill in if you're interested. Undefined, awesome. Three more that we need to fill in. Null, perfect. Undefined, awesome. That is null, perfect. Undefined. Nan is not actually a primitive type. It is a value. Is not actually a primitive, but we've got one more. It is a value. We have one more. But we've got one more. It is a value. Primitive types in JavaScript. Primitive. If you ever want to find out anything, oh, this one just lists 5. If you ever want to. Seems like someone's visited this page before, and apparently I still have my dark screen on. There we go. Seems like someone's visited this page before, and let's see what we've got here. Boolean, null, undefined, number, big int, string, and symbol, undefined. That's probably why it didn't come to mind immediately. That's probably why it didn't come to mind. You can research this. Undefined. That's probably why it didn't come to if you want to, but it won't come up at any point during Lighthouse, during bootcamp. Okay. If you want to, symbols. The entire point of a symbol is that it is unique value. The entire and it can be used to uniquely identify things. And that's about all there is to a symbol. And the value of that, I don't think you'll see this early on. Okay. So here we go. Here's our 5/6 primitive data types. And what do we know about primitive types? Primitive data types are immutable. Primitive data types are. So what does that mean? You cannot. So what does that mean? Cannot alter the value after it has been created. Alter the value. Okay, so let's take a look at this with some created code. Okay, so let's take a look at this with some, let's call this code primitives.js. There we go. Let's call this primitives.js. Okay, so let's take a look. So we have Boolean, right? Okay, so let's take a look. So we have, which is true or false. Boolean. We have, go away, thank you. Which is true or string. Let's call that str. Go away. I am a string. Let's call that. What else do we have? We have I am a string. Undef. What else do we have? We have. By the way, it is considered extremely poor practice to ever explicitly assign undefined to something. Undefined is the initial state that all variables have. So it is a special value that gets assigned by the JavaScript engine. And so if you're explicitly assigning it to something, it can become very hard to debug your code because then it's not clear, did I forget to define it somewhere or did I set it to undefined? Okay? It's a better practice to, or did I set it to undefined? Set it to null or something like that. Or empty string or something if you need to reset the value. Try not to ever set something explicitly to undefined if you need to reset the value. And then we, of course, have our if you need to reset the value. Floating point numbers. And we, of course, have okay, so let's take a look at string, because I think that'll be the easiest one to demonstrate. Have you looked at any kind of string methods? Is there anything that comes to mind? What can you do to a string? Any kind of string methods? Is there anything that comes to mind? You can get the length of it. Yeah. What about things that alter the string? You can get the length of it. Oh, I love this new mode for VS Code. It'll actually auto hint for you all the different different things that you can do to whatever particular thing that you're working on. But they've started putting these stars at the top for the most frequently used thing that you're working on. So you don't have to scroll through it. But they've started putting these stars at the top. By the way, going through lectures is a great time to see professional devs use their tools. Use their IDEs to their advantage. Cool. So let's look at what else we can do. We could split. We could replace. Let's do something like we could split to uppercase. Let's do something like. So if I console log this. Let's do something like. So if I console log this. Next thing. This is why I have to have my to-dos, because otherwise I'll be all over the place. We always want to have an idea of what our code is going to do before we run it. It can still surprise you, but that's good. You should have an idea based on your understanding of your code or what is going to happen, then run your code. Okay? And then your idea will either be founded or you'll have to change the way that your understanding about something. Okay? But this is how we grow. So your understanding about something. Okay? But this is how we grow. So let's comment this out for right now. What are we going to get from this console log? Comment this out for right now, based on what you see here. I don't know if you've used this particular method or not. Based on what you see, it should all be uppercase. We should see I am a string, all in uppercase. It should all be uppercase. We should see I am a string, all in uppercase. Let me do that again. Oh, by the way, up if you want to get to your previous command. Do that again. Fantastic and bash. I am a string. If you want to get to your previous command. Awesome. So we perform some kind of operation on this string, right? Awesome. So we perform some kind of. So what do we expect string to be? String, right now. Here, so what do we expect? We cast it to uppercase. We got now all uppercase. Here, so what do we expect? We cast it to uppercase. What is string going to be? Now all uppercase. Here, so what do we cast it to? What is string going to that? It's still the original one. Exactly. We didn't actually do anything to the string itself. Okay. Exactly. We were not able to change this string's value. Okay. We were not able to change. So that's what we mean where we talk about. Okay. Primitive types are immutable. That's what we mean where we can't actually do anything to that value. We can reassign it. Like if I change this to a let, then we could say, like if I change this to a let's get rid of this. Then we could say string equals string to uppercase. Let's get rid of this. Right. And now string equals string to uppercase when we console log str, and now it's actually been changed, but we reassigned it. When we console log str, we actually said string equals string to uppercase. Okay? When we console log str, we didn't actually change this original value. We got a whole new value. We didn't actually change this original value. We got a whole new value. Any questions about primitives? Yes. Any questions about primitives? Yes. Any questions about the string method splice? Any questions about the string method splice? Let's find out. Any questions about oh, not splice. There we go. Let's find out. The splice method changes the contents of an array. Is there a string method splice? Let's find out. The splice method changes the contents of an array. Is there a string method split? Was it split? Or were you thinking of slice? Was it split? Okay. Yeah, splice is actually an array method. You will find out later in the course why this says string dot prototype dot whatever the method is. The short answer is all strings have the ability to do whatever's on the other side. So all strings can slice. All arrays can splice. We have substring. Substring is pretty cool. You return just the portion of a string. So we can split it into smaller strings. There is replace. So we can split it into smaller strings. There is replace. So we can split it into smaller strings. Yeah. There is replace. So we can split it into smaller strings. Yeah. There is replace. So we can split it into smaller strings. Yeah. There is replace. So we can split it into smaller strings. Yeah. There is replace. So we can split it into smaller strings. It's not. So for the recording, for the future. It's not. The question was, so if we just do some kind of operation for the future, it's not. The question was, what happens to this? Right? Essentially, some kind of operation in the future, it's not. It is actually not stored in memory. Right? Essentially, some kind of operation in the future, it's not. It is actually not stored in memory. Right? Essentially, some kind of operation in the future, it's not. It is actually exactly. So it's important to note that if you want the result to happen, you have to put this into memory. Okay, you have to store it inside of a constant. If we do this operation here, and we'll run this, you have to store it inside. We'll see that our console log fired. But all that happened here was JavaScript said, okay, I'll take string, I'll convert it to uppercase. JavaScript said, okay, and then I'm going to move on to the next line of code. And the garbage collector comes along and actually probably isn't even garbage collected. It's probably just immediately thrown away. And the garbage collector comes along and actually probably isn't even garbage collected. It's probably just immediately thrown away. And the garbage collector comes along and actually probably isn't even garbage collected. It's probably just immediately thrown away. Yes. Actually probably isn't even garbage collected. It's probably just immediately thrown away. Yes. Actually probably isn't even garbage collected. It's probably just immediately thrown away. Yes. Actually probably isn't even garbage collected. It's probably just immediately thrown away. Yes. Actually probably isn't even garbage collected. It's probably just immediately thrown away. Yes. Right. 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 It's kind of a bit of both. So the question is in some programming languages, was that specific to JavaScript, or are we just reading about any language? In some programming languages, there's destructive and non-destructive. In other words, do they change the original value? Do they not change the original value? And we can talk about that with something like in JavaScript. Let's say we have an array with something like don't all caps. In JavaScript, let's say we have an array with something like and it's important to know that something like array.map returns a whole new array, and it doesn't actually change it. But array.map array.sort, it doesn't changes the original array. And these are some gotchas that you have to check the documentation for. These are some gotchas. When I was first starting out, I would Google, does map give you new array or does it change the original array? Or you can just play with it. You can test it out either in a JavaScript file here or in your REPL. I highly recommend that you jump into REPL. Has everyone seen the REPL? Was it part of the beginning course? Has everyone seen the REPL? Was it part of the... And you can just jump right in here and start typing JavaScript. Is that big enough for everybody? I can bump the size up. You can just jump right in here and start typing JavaScript. Is that big enough for everybody? So then we can do things like... Well, it is already sorted. So then we can do things like... Well, it is already sorted. So by calling reverse on our array, we actually mutated the original array. It's actually changed. Reverse on our array, we actually mutated the original array. As we pointed out in our README here, as we pointed out, arrays don't appear in our list of primitive types. So they don't fall under this necessarily, that their values are immutable. Okay? Arrays are necessarily that their values are immutable. When we get started, we'll start talking about objects in a little while, but everything that's not on this list in JavaScript is an object. Everything that's not, every single thing that you can think of in JavaScript, every array, every object, obviously, every function, they're all objects. Every array, every object, obviously, every function. So, where were we? Any other questions about that before I switch to replace? So, where were we? Any other questions about that before I switch to replace? So, where were we? Any other questions about that before I switch to replace? Oh yeah, absolutely. Okay, so let's look at that. Absolutely. Okay, so let's look at that. Comment this out for right now. And comment this out. Cool. Okay, so and comment this out. Cool. Okay, so what are we going to see? Cool. Okay, so what are we going to see? Let's find out. Clear? What are we going to see? Let's find out. Undefined. Clear? So undefined is the initial value that every single variable gets set to. Because when JavaScript creates a variable, it has to create a value that goes along with it. It's not just a spot in memory, you have to put something in there. So the very first thing it does is put in this special value undefined, meaning it has not yet been defined. Because this is actually performing two separate operations for you. It's creating a space in memory and then assigning it a value. It is equivalent to that. JavaScript sets the area aside in memory, sets the default value to undefined, and then you assign a value to it. So this is absolutely one place where you will hit undefined. If you try and use something before it actually gets defined, or as we'll see later, you try to access some part of an object, some value in an object that doesn't exist, you'll also get undefined. Cool. So where was I? I need string. Cool. So where was I? I need string. Don't need this. All right. Don't need that. Don't need this. Oh, that doesn't make any sense. I am the walrus. Oh, there we go. Anybody get that reference? Okay, awesome. As long as there's one person in every cohort who laughs, I'm fine. Okay, awesome. Even if it's just my previous students who are listening in and they laugh, that's totally fine as well. Awesome. Okay. Even if it's just my previous students who are listening in and they laugh, let's console log string. Has anyone come across replace before? Let's console log string. So what replace is going to do is it's going to walk through whatever string that we passed in, looking for a value. And when it finds that value, it will replace it with whatever you pass as a second argument. So initially we have I am a string, and I guess we'll change this to the to make sure that it's bang on. And when we run this file, to make sure that it's bang on, we get I am the walrus, which is a reference I barely get. Okay? We get I am the walrus, which is a reference I barely get. So we can do all these different things, but we're not actually mutating this original value. We're not actually doing anything to it. We're creating a whole new thing. Even if we said something like, we're creating a whole new thing. Even if we said something, we're going to add on, we're creating a whole new thing. Even if we said something, and we're actually going to add something to the string. We're actually going to perform some string arithmetic here. We're going to have I am the string plus, we're actually going to perform more things. We're going to have I am the string plus, we're actually going to perform more. If we didn't do this, we're going to have nothing would change. We would still get the original I am the string. If we set this, we store it somewhere, I am the string. Then we'll actually get that changed value. But it's important to note that this completely went away. It's been totally thrown away after this step. String has been str, has been reassigned. This value didn't change. It got thrown away and a new one was created. Okay? This value didn't change. It got thrown away and a new one was created. So let's try, let's use what we've got, our current JavaScript knowledge, try to create and store a list of something. This is the point in the lecture where I ask for a noun, and hopefully you come back at me with a noun. Otherwise, I'm just going to pick one at random. So we need something that you might have multiple of, that you have various different adjectives that we could use to describe. That children, various different adjectives that we could use to describe. There we go. Children, various different adjectives that we could use to describe. There we go. Okay, so we want to be able to store information about our children. Okay, they might not be ours, they might be kids that we know. Who knows? We're just going to create a bunch of children. I want to. This is my problem. As programmers, we are problem solvers. Okay, so the problem statement is I have a bunch of children, and I need to keep track of their and I need information. Keep track of okay. So there's our problem statement. Information. So okay. So why don't we get started? We might have child one. Why don't we get started? We might have might be child one. Alice. Okay. Might be. What's another child's name? Okay. Might be Bob. What's another child's name? Okay. Is it gonna be Carol? What's another? Thank you. Child's name. Okay. Cool. Is it gonna
So
be
now
Carol?
we have
3 children. So if I have 3 children to keep track of,
So now we have
I've got them stored
if
in
I have
this
3
file.
children to keep track of,
Cool.
now we have
So how would I? Let's say whenever I run. Cool.
So how
No
would I?
children. Let's say whenever I want to see all the kids get printed to the console. No children.
Let's say whenever
I want to see all the kids. What's my next step here? To the console. Console log. Console log child 1, and then console log. Since programmers are lazy, and then just copy and paste. There we go. And now when I run this, I see Alice, Bob, and Carol. There we go. Awesome. And now so far so good. I see we're able to keep track of Carol. Okay. Now, so far so good. Let's say that we need to keep track of another piece of information. What other piece of information might we want from a child besides their name? Track of another piece of information. What other piece of information might we want from a child? Given what we've got at our disposal, okay, how are we going to keep track of the age? Given what we've got, could we do something like could we do child 1 age? Something like that. Does that sound fine? 12. How about that? Alice is 12. Something like that. Does that sound fine? Cool. Child 2 age. 7. There we go. And child 3 age. There we go. Is 8. And child 3. Perfect. Okay, but now when I run my file, I'm not able to see their ages. When I run my file, I'm not able to see what's going on here. So I would have to add that in. When I run my file, I'm not able to see what's going on here. So to each of the console logs, add that in. Did you know that console log takes multiple arguments? To each of the console logs, add that in. Did you know that console log takes multiple arguments? To each of the console logs. Am I spelling child right? It looks so foreign here. Maybe it's because of the. Am I spelling child right? Is that correct? So foreign. It looks really weird. It's because of the. So anyway, so now we see. Is that correct? So foreign. It looks really. Let me move that closer to the top of the screen. How are we doing for time? 10:30. Is that correct? Alice 12. Let me move that closer to the top of the screen. Bob 7. Carol 8. Alice 12. Awesome. Let me move that closer to the top of the screen. Bob 7. What else might they have? What else might children have besides a name and an age? What else might toys? Children have. So, are we going to continue on with our toys thing here? So, child 1 toy equals what kind of toy did kids have? Car. I like it. Equals what kind of toy did kids have? Feel free to shout out suggestions. Equals what kind of toy did kids have? Feel free to shout out robots. Equals what kind of toy did kids have? Feel free to shout out robots. Equals what kind of toy? Dolls. I like it. Robots. Perfect. Okay, and then we've got to go through here, and we've got to update child 1 toy. Perfect. Okay, child 2 toy here, and we've got to update child 1 toy, child 3 toy. 2 toy. Awesome. And then we run this code and, okay, Alice 12 car, Bob 7 robots, Carol 8 dolls. Okay, I could format this a little bit differently. I could give them all, you know, this is what their name is and this is the value of it differently. But I could give them all, so far so good. This is what their name is. We were able to take, in only 18 short lines of code, we were able to capture the information from 3 children, their ages, their names, their ages, and their toys. From 3 children, their age, but their names, their you can see how, if we want to keep adding on to this, this is going to get unmanageable at some point, right? Adding on to this is going to get. Would you want to continue adding children to this file? If I hired you and I said you've got another 7 kids to add to this file, you wouldn't want to maintain this, right? So what are some options for us? We already have, right? Yes. So what are some options for us? We already have, right? Yes. So what are some options for us? Okay, so you're jumping right ahead to objects and key value pairs. Let's say for instance, so you're jumping right ahead to objects and key value pairs. Let's say for instance, you're jumping to the end. Spoilers. Spoilers. Let's pretend that we don't have access to this object yet. Spoilers. Let's pretend that we don't have. Yell that out at like 11:05. Object yet. Okay. So let's pretend that we don't have access to objects yet. What do we have access to? We've got arrays, right? So what would it look like if I refactored these kids' names into an array? What would it look like if I refactored these kids' names into an array? What would it look like if I refactored these kids' names into square brackets? Okay. What would it look like if I refactored these kids? And then we do something like Alice, okay, Bob, and we do Carol, something like Alice, cool, okay, Bob. So now if we want to see this, then we would just console log. So now if we want to see children at 0, then we would just console log children at 1. So now if we want to see children at 0 and children at 2, right? So we can access things inside of an array based on their index, right? With the square brackets. So we can access things inside of an array. Okay, let's see if the functionality of our code has changed it. With the square brackets. Alice 12 car, Bob 7 robots, Carol 8 dolls. Let's pluralize this so that Alice doesn't feel left out, because all the other ones have multiple toys. Let's pluralize this so that Alice doesn't feel left out. So can we do the same thing with ages? Okay, can we do the same thing? So we got 12, 7, and 8 ages. Okay, let's comment this out, and then we can change this to ages 0, and then we can change this to ages 1, ages 0, and ages 2. And presumably no difference. Always work iteratively, and presumably that's probably the best advice I can give you. If you write out 50 lines of code and then it breaks, it's hard to see what went wrong. If you refactor 3 lines of code into 1 line of code, run your code. Make sure everything's still working as expected. Okay? Don't make too many judgments about what you think is going on, because it could be really hard to debug later. Make too many judgments about what you think is going on. Let's do toys as well. Make too many judgments about what you think. Const. Let's do toys equals cars. Const. Robots equals and dolls. Awesome. And then we have, let's access our toys array. Toys at 0. And we have, let's access our toys array. Toys at 0. Toys at 1. And our toys array. Toys at 0, toys at 2. Okay. Has our refactor worked? Toys. Yes. 2. Awesome. Okay. Has our refactor worked? A more maintainable file? Yes. Ignoring all the commented out code. Would you be more willing to add children to this one every day? If I said I've got more. Okay. Add children to this one. But we've also intrinsically linked these arrays together, right? The first value in this array corresponds to the first value in this array, which corresponds to the first value in this array, right? That's very tightly coupled. If we had, let's say, a child has a name and an age that's indisputable, but maybe they don't like child, maybe they don't have anything that's indisputable, what if we didn't put an entry in for this one? That the kid didn't have toys, or any of the other attributes that we want to give them, any of the other adjectives that we can use to describe have toys, or any of the other attributes. We're going to have to find some way of keeping these in sync, right? This Bob has to map to 7, has to map to robots, which means that every single array has to be updated in the same way. If, let's say we were running like a school or childcare center, and Alice graduated, then we have to remove Alice and all of Alice's information from every single array, right? Otherwise, we've lost our mapping. Because if we just took Alice out of the first array, now we have Bob 12 cars, Carol 7 robots, and undefined 8 dolls. Which is not what we're looking for. Did anybody know that when you try and access, which is not where were we, children? Did anybody know that outside of the bounds of an array, where were we, children? You get back undefined. Outside of the bounds of an array. So if you try to access an index that does not exist, you'll get undefined. So if you try to access an index that does not exist, this intrinsically links everything together here, right? So this is intrinsically links kind of difficult to maintain together here, right? So this is, before we jump to the O word, how could we refactor this to make it slightly easier to, how could we refactor this to make it keep track of everything? Easier to, what, for interest's sake, keep track of everything. What does an array contain? For interest's sake, keep track of everything. What does an array contain? Sorry? For interest's sake. It has elements. Yeah, absolutely. And they could be any of the values in JavaScript. It has
elements. Yeah, absolutely.
It could be an object, it could be a primitive, it could be another array. But in general, arrays contain related information, right? Like the children array is an array of children. Ages, they give some context to the values that are in here. We don't see, they give some context to the values that are in here. We don't see one of our children is 7, one's 8, one's 12, one's 7, one's 8, and one's banana. That doesn't make any sense, right? One of these things is not like the others. So how can we use the fact that we use arrays to contain like information to refactor our code into a slightly better form, a more maintainable form? To refactor our code into a slightly better form. Arrays inside of arrays. I like it. Okay. Arrays inside of arrays. I like it. Here we go. Okay. So we're going to have a children array. Okay. So we're going to have and each child is going to be an array. So we're going to have and each child is going to be an array. Cool. So another thing that I like to do to keep myself, make sure that I never run into that error where you forgot a closing curly brace or a closing parens or a closing square bracket, is I like to open and close my things before I start filling them in. I didn't get to this point and start typing in here, because then maybe I'm going to forget to close them. Okay? I open them all, because that way I make sure that I've closed them all. Okay? I close them all, that way I make sure that I close them all. Okay, there you go. I close them all, that way I make sure. So, here we'll have Alice, there you go, who was 12, and likes cars. There you go. And then we'll have Bob, and who was 7, and likes robots, and who was 7. And then we have Carol, and likes robots, who is 8, and likes dolls. And then we have Carol, and likes robots, who is 8. Okay, so this isn't going to work for us anymore. Now we've got our children all in one spot. Each one has their own array of values. All in one spot. Is this even easier to maintain? You could argue. If I asked you to add another child to this, would that be something that you could do? If I asked you to add another child to this, but we can no longer, just console log. We don't just have primitives anymore. We've actually put everything into a data structure to contain this information. So how do I see this? Because now if I run, how do I see? I don't get anything back. Because now if I run, how do I see the children inside of this? How do I see the children inside of this? Well, we can let's just try console logging children inside of this. Well, we can find out what happens. Just try console logging children. Not bad. Not bad. Not, like we were getting before, but not terrible. We can, at least we can do it all in one line, and we can see all of the information about them. At least we can do it all in one line. What about if we wanted to iterate over this array and see everything? What about if we wanted to one at a time? We want to see one element at a time. How would we do that? One at a time. For loop. Okay. How would we do that? What do we have available to us as for loops? What do you like? How would we do that? We can move on. We can explore for loop. Why don't we start with the C style for loop? We can move on. That is let I equals 0. I is less than. Where do we stop? I equals 0. I is children dot length. Where do we stop? I plus plus children dot length. Cool. Any questions about why we call this a C style for loop? Cool. You could probably guess. Yes. Any questions about why we call this a C style? Because it comes from the programming language C. It looks an awful lot like C. That's why we call it the C style for loop. C was invented many years before JavaScript came along. So we refer to this as the C style for loop to separate it from the other styles of for loops. Okay. We refer to this as the C style for loop to separate it from the other styles. I want to be able to see each child. Right? So presumably we're going to console log child. Right? Have you use template literals yet? Going to console log. Oh, cool, awesome. So we can do that. So I could say something like, I want to get the child's name, right? So I'm going to throw that into some JavaScript in here. I want to get the child's name. How do I get access to the child's name? In here. I want to get the child's name. How do I get with the index? Right. Okay. So index into the. How do I get with the index? Children array? Okay, so index into the children array. How do I get into there? Index into I? Can I just say I? Or is it okay? Square bracket I. Can I just say I? And then square bracket 0. Square bracket I. Cool. Okay. Can I just say Alice is let's 0. Square bracket I. Cool. Children at I is at 1. Cool. Children at and they like at 1. Children at and they like at 1. Children at and they like and children. Children at and at I at children 2. Exclamation mark I at cool children 2. Okay. So that's a nice long cool line of code. Okay. What do we think we're going to see when we run this program? Line of code. Okay. What do we think we're going to see when we run this program? Line of code. So you're thinking we'll see something like Alice is 12 and they like whatever the toy is. Alice is 12. Let's take a look. And they like Alice is 12 and they like cars. Bob is 7 and they like robots. Carol is 8 and they like dolls. Alice is 12 and they like cars. Was that output surprising to anybody? No. And they like dolls. 12 and they like cars. Cool. Was that output surprising to anybody? Although our data structure is a lot easier to maintain. Although our data structure this is still kind of gross, right? To maintain, because if someone else is looking at this, right? And that someone else might be you a couple months later. Because believe me, what you're working on right now, you'll completely forget when you start moving on to other things, okay? So you come back to your code and then you say, completely forget when you start moving on to other things, okay? So what is 0? What significance does this have? And I've got this square bracket I, okay, so that's an iterator. I must be iterating over an array. Okay, but what does all of this mean? It gets kind of lost. What relevance this has? Like, what is children at I at 1? What? Is it a name? Is it an age? Is it a child? Children at I at 1. You don't know. You're going to have to look through the code and say, okay, going into the children's array. Oh, okay, here's the children's array. And you just kind of have to figure this out. Children's array, right? Okay, here's the children's array. And you just kind of have to. That was our C-style for loop, right? Okay, here's the children's. What if we try one of those 4 ofs? That was our C-style for loop, right? Okay, here's the children's. What if we try one of those 4 ofs? That was our C-style for loop, right? Okay, here's the children's. What if we try one of those 4 ofs? Object. Oh, template literals or string interpolation? Is it better to do this? It's not necessarily about good practice or bad practice in that regard. You can absolutely just use the plus and just have all of your strings be concatenated together like that. I prefer this because it makes it read like a sentence. And there's a lot of times where you say, and there's a lot of times where you say, and you forget about, and there's a lot of times where you say, and you forget the spaces in between, right? Whereas this writes like a sentence in English, so it's less that you're going to miss out. And you also have this like elaboration, like if I wanted to add an exclamation mark to this sentence, I have to come down here and say, okay, and now it has an exclamation mark on it, right? I have to come down here and say, okay, here I just prefer to use template literals because you can write it out like English, and there's less chance that you're going to forget something like a space or some punctuation or something in your final output. There's less chance that you're going to forget. But use whatever you're comfortable with, whatever makes sense to you. Okay. Use whatever you're comfortable with, whatever makes sense to you. Okay. No. As far as you're concerned, no. There's everything. It's good. Creating a string. This is creating a string and then passing it to the console log function. This is creating a string. This log function. So whatever comes back from here, we could also have. This is creating a string. This log function. So whatever comes back from here, we could also have
This is creating a string, this log function. So whatever comes back from here, we could also
and just put it into a variable instead.
So whatever comes back
Okay.
from here, we could
And just put it into so whatever this
variable
is,
instead.
these get interpolated. That means JavaScript grabs the value out of memory. It goes, okay, I have to look inside the children. There must be some object in memory called children. Or there must be something in memory called children. Yes, there is. Okay, give me the ith element of it, whatever that evaluates to. And then give me the 0th element that comes back from that, whatever that evaluates to. Is this square bracket syntax? Have you done enough arrays inside of arrays square bracket for this not to look super strange? Arrays inside of arrays? Because remember that not to look super strange returns an array. That's why we can square bracket into it. Okay, that's why we can look at it. And this returns, what does children at I at 0 return? This returns, what does children at I at 0? Well, this children at 0 will return Alice, which means that we could do something like children at 0 will return Alice, which means that we call two uppercase on it, right? Children at 0 will return Alice, which means we call two uppercase on it. Always try to think about what data type you're actually getting back. Always try to think about what data type. And then hopefully this will be slightly less confusing as you're trying to do things like retrieve, go into an array, retrieve one of the elements of the array, look inside that array, and then call two uppercase on the elements of the array. If it makes more sense to you to do it, and then call two uppercase on the elements of the array. If it makes more sense to you to do it, and then call two uppercase on the elements of the array. If it makes more sense to you to do it, and then call two uppercase on the elements of the array. If it makes more sense to you to do it, if it makes more sense for you to do it like that, then do it. So this, actually, hang on, it wasn't, we were calling two uppercase, weren't we? Actually, hang on, it wasn't, we were calling two uppercase, weren't we? Actually, hang on, it wasn't, we were calling two uppercase, weren't we? So we could swap this out, just for comparison purposes. I want to put these side by side. So we could swap this out. Just for comparison purposes, I want to put these side by side. Okay. So if it makes more sense to you, you can pull everything out and work your way through it. If it makes more sense to you, rather than trying to do it, you can all in one line and work your way through it. If it makes more sense to you, rather than trying to do it, you can all in one line and work your way through it. If it makes more sense to you, rather than trying to do it, you can all in. When you're calling multiple functions, well, in the end, we're only calling one function. When you're calling multiple functions, well, in the end, we're only calling one function. On this. But yes, it depends on what was returned from here, but yes, it would chain them together. So we know that two uppercase returns a string, right? As we saw before, we said str equals str dot two uppercase. We got back a string, right? So then we could do something like two uppercase. We got back a string, right? Dot length, we could do something which would give us then the length of the uppercase string, right? Or we could call of the uppercase string. Split on it. And maybe we want to split on every space. And then we want to join it back together with a comma in between. And then we want to join it back together. I kind of just want to see what this looks like. Comma in between. Interesting. I kind of just want to see what that's going to be too weird. Interesting. Okay. So there we go. We're going into children. We're looking at the ith element. So we're getting that back. So that resolves to an array. We're going to look at the 0th element. So we're getting that back. So this resolves to a string, which we're going to call uppercase on. Then we're going to split and turn it into an array. And then since this returns an array, we're going to call join on it and put a comma in between each of the words in the in between. So that's split is not going to, let's say, Alice, split is not going to, Neverland. There we go. Just so we can see something. Split is not going to, Neverland. All caps, just so we can see something. Comma separated, split on the space. All caps, just so we can see something. All in, comma separated, one ridiculously long line of code. Okay? But you can absolutely keep chaining that on as long as everything, whatever to the left of the dot, evaluates to the data type you think it is. Okay? If this did not evaluate to something that had a two uppercase, then this code would fail. If this came back and this was actually the number 42 came back and this was actually name.toUppercase is not a function. because now this is 42. And it's actually that one that failed, so let's see it in this is 42. And it's actually that one. There we go. So let's see it in 42. Errors. It's actually. Have you learned to love errors yet? Okay, you will. Errors. You will. Errors are good. They steer us in the right direction. You will. Right? Okay, so what is this error trying to tell us? It's saying that in the right direction. You will. In Children.js on line 35. Saying that. Okay, let's check it out. Line 35. In Children.js, there is an error at this point where this caret is, and then we get some explanation of the error here. Children at I at 0.2 uppercase is not a function. Because if we jump into the REPL and we say const num equals 42, and then we say num dot and we say const num equals 42 uppercase, say num dot and we say const 2 uppercase is not a function. Okay, uppercase. So numbers don't know what you mean. What's the uppercase of 42? So what's the lowercase of 42? What's the uppercase of 42? Okay, so we get this is not a function, and then we get this wonderful thing down here. Okay, what's this called? We get this is not a function, and then we get this. This is the stack trace. Exactly. This is the stack. So every time you start executing code, it gets put onto the stack, and then if something else happens and something else happens, and as that code finishes up, it comes back off the stack. So we get to see what worked all the way up from Node. So we get to see the actual internal processes of Node that we invoked by saying, Node the actual internal children, and we can see that it got all the way up through all these internal modules and everything to our actual line of code through Children.js, line 35, character 30. That's what the secondary one is. So 30 characters into here, if we were to count it out, that's what the secondary one is the beginning of 2 uppercase. Into here, if we were to count it out. So there's a lot of information here, okay? And it can be really helpful for debugging. A lot of information here. Errors are much better than running your code, and it doesn't do what you expected, but it also doesn't throw. That to me is the scariest time. But it also doesn't throw. I love, if my code doesn't do what I want it to do, I want to see an error because it's going to tell me what I did wrong. If my code doesn't do what it would make me look back at this and say, I'm not actually getting the data that I think I'm getting. Because I tried to call 2 uppercase, and that wasn't what I thought it was. I tried to call, okay, you spoke, I believe that, Nemo brought up LSD yesterday, I saw it in the notes, right? So logic, LSD yesterday, I saw it in the notes, syntax, right? And data. So which one from LSD failed us here? And data. So which one from LSD failed us? Data, absolutely. Because the question is, from LSD, do I have the data? Absolutely. Because the question is, in a format that I expect? And that failed. Let's say I was getting this from a server somewhere in the cloud. I'm pulling information in, and I thought that I could just iterate over everything and call 2 uppercase and see a nice sentence written to the screen, and instead I got errors in the context. Okay? The data did not conform to my expectations. Okay? The data. So let's change this back to my expectations. Alice. Okay? The data. So let's change this back to my expectations. So Alice. We are able to. Let's change this back to my expectations. So let's just get rid of these. We are able to. Let's change this back to my expectations. So let's just get rid of these. Cool. We should still. Oh. Let's just get rid of. By the way, if you're in the REPL, you can get out with .exit. Or the universal Control D. You can get out with. And yes, Mac users, I meant Control. I didn't mean Command. It is actually Control D. It's the universal quit. Control. Yes, I didn't mean Command. It is actually Control D. It's the universal quit. Control. Oh yeah, it actually does. It just clears the console. It actually, it fakes you out because what it does is it puts a number of it just moves you to the top of the screen. All the rest of your history is still here. It's just cleared the screen. And you can do this from. The rest of your history is still here. It's just cleared the screen. And you can do this from inside of your code. So here we're going to iterate over. We're going to console log a whole bunch of stuff, but then we're going to call console clear. Here we're going to iterate over. We're going to console log a whole bunch of stuff. So we're going to do node children. Here we're going to iterate over. We're going to console log a whole bunch of stuff. So we're going to do that's right. Children.
Here we're going to iterate over.
See how useful that error message was?
Children.
Isn't that fantastic? It told me exactly what the problem was.
That error message was?
What is the problem?
Isn't that fantastic?
It told me exactly what the problem was.
That error message was?
What is the problem?
Isn't that fantastic? It told me exactly.
Name
what the problem
upper
was.
is not defined because remember I had refactored the code. Name upper is not defined because remember I had to create a name upper variable that I had then put into my string. And when I erased all this or commented it all out, I lost that name upper. It no longer exists. So my code is throwing an error. It no longer exists. So because it's saying I don't know what that is. Okay, so we set it back to how it originally was.
Saying I don't know what that is.
And
Okay, so we set it back to how it originally was. Saying I don't know what that is. And
look at that.
Okay, so we set it back to how.
So it's actually printing everything, but then it's immediately clearing
So it's
the
actually
console.
doing.
And if you wonder how fast
but then it's immediately
JavaScript
clearing.
runs, it's blazingly fast.
If you wonder how
We're
fast
talking on the order of
JavaScript
hundreds of thousands of operations per
If
second.
you wonder how
Okay.
fast talking
So
on the
it
order of
literally
hundreds of
wrote
thousands of operations
these
per second.
milliseconds before it cleared the console. Too fast for us to even see
Milliseconds
a flash of what was going on. Like we didn't even see it flash. It just immediately cleared it. Okay. So if you need to, this is actually how I make rudimentary terminal animations. You can actually do it in the same way that they make cartoons, where you create an image and then you clear the console, and you create an image and you clear the console, and you create an image and you clear the console. I can show you how to do that later if you're interested. But console.clear.
I can show you how to do that later.
Any other questions before we move on?
But console.clear.
Oh, yes, I know what I wanted to do. I wanted to look at how are we doing for time? 10:59. Okay. Why don't we leave it at this point because it's 11 o'clock? Okay. And think of any questions that you might have, and after the break, we'll remember that we have objects at our disposal, and we'll see how we can use it to try and solve our children problem. And we'll see how we can use it. We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem. And we'll see how we can use it.
We'll reconvene at 11:10.
Children problem.
All right. Couple people coming back. Any questions come up over the break, or was it just a fight to get to the coffee machine? Was the question, why are there 60 of us and there's only one coffee machine? Was that the question? Was the question, why are there 60 of us and there's only one coffee machine? Because it's doing a really good job. Yeah, it's doing a... Why are there 60 of us and there's only one coffee machine? Because it's doing a really good job. Yeah, yes. Who has thought about hacking the coffee machine? Yes. You've considered it, though, right? Who has thought about hacking the coffee machine? Right. You've considered it, though, right? When they show up to service it, they pull out like a laptop and USB into it to check and see what's going on. Yeah, that's my symbol for USB. Yeah, like a laptop and USB into it to check and see what's going on. Yeah, that's my symbol for USB. Yeah, laptop and USB into it to check and see what's going on. Did anything come up about children? About arrays? Come up about children? About all this jazz? About arrays? Come up? About children, about all this jazz, about arrays, come up, about template literal, all this jazz, about arrays, come up, about template literal, all this jazz, about arrays, come up. No, it doesn't. That was one of the things that I was going to bring up. Is let's hop into Node here. That I was going to bring up. Let's hop into go back into Node, and then let's say I have an array of go back into Node, and then let's say I have an array. So if we just console log this, we see that the square brackets. But if we put it inside of a template literal, we see that the square brackets. But if we put it inside of a template, we actually get slightly different syntax. You notice that there's no spacing in between. There's no square brackets. Slightly different syntax. You notice that there's no spacing in between, there's no square brackets. Slightly different syntax. You notice that there's no spacing in between, there's no square brackets. Slightly different syntax. Right. So if we did r.push, right. So if we look at it, we see 1, 2, 3, 4. But we put it inside of a template literal, we get 1, 2, 3, 4. It's because we put it inside of a template literal. The template literal is calling toString on the array in an attempt to make it work for you, make it look more like you would want to write it in a sentence. Make it work for you, and it can like you would want to write it. It actually, the template literal, this thing, when it evaluates this, it actually calls toString on it. It doesn't work the same way as console log, which would output this. It doesn't work with the square brackets and the spaces in between, and showing you the different types that are inside of it. Template literals will call toString on it, which can be a little confusing if you're trying to do something like write your own concatenation logic, right? If you write your own join function for low tide. That was yesterday, right? Yes, exactly, because it looks like you succeeded. That was yesterday, right? Even though you might not have. Yeah. So that's the secret, is template literals actually call toString on any objects that are inside of it to see what it looks like. Actually call toString on any objects that are inside of it to see what it looks like. Awesome. Okay. So review of primitive types. Okay, we're over the halfway point, and we're 1/4 of the way done. We're doing pretty good. I'll release you around 2 in the afternoon. I hope you brought food. We're doing pretty good. I'll release you around 2 in the afternoon. I hope objects. So we saw that although we got this to a decently manageable state, adding more and more children over time who may or may not have various different adjectives that we want to describe them. They may or may not have different toys. They may or may not have hair. They may or may not have whatever, glasses, something like that. They may or may not have. This is more manageable, but not manageable in the long term, right? Once again, but not manageable. Nima probably brought it up yesterday, but once again, Nima probably brought it up yesterday, but and this is actually, it's actually a triple equals because we also match on the type, and this is actually. It's actually a triple equals because we didn't get the on the type. That laugh, I thought it was going to be in my head. For the recording, huge applause. Okay, always use that joke in your lecture. For the recording, yes. Huge applause. Another way to say this is efficient. We want to get the most amount of work done with the least amount of effort. Efficient, right? So that we can move on and get other things done with the least amount of effort. So we want to write easily readable and easily maintainable code. Okay. And I think we can agree that this fails on both counts. because it's not that easy to maintain, especially if we had more than 3 values. It's not that easy to maintain, and it's not that easy to read what's going on here. If you handed this to someone else, how would they know what children at I at 2 is? If you handed this to someone else, how would they know what there's no way for them to know. So, well, they'd have to read your code. They'd have to read more than they should to figure out what's going on. They'd have to read your code. They'd have to read more than they should to figure out what's going on. Let's get to. They'd have to read more than they should to figure out. So the big thing for today. Let's get to objects. Okay. So objects. Objects. As we talked about earlier. Okay. So if it's not in this list, it is in fact an object. As we talked about earlier. Okay. So if it's not in this list, it is. What is an object? As we talked about earlier. An object. If it's not in this list, is a key value store. An object. It is a data structure that holds keys and values. It is a data structure that holds key and values. It is a data structure that holds keys are strings. And the values can be any valid value in JavaScript. Any of these primitives. It could be an array. It could be a function. It could be an array of arrays. It doesn't matter. As long as it conforms to this key value system, it doesn't matter. Then as long as it's an object conforms to this, then we can interact value system. If you conforms to this, then we can interact other programming languages. If you refer to these things as different things in Ruby, which you'll learn later on, we call them objects. Refer to these things as different. But you might hear about things like hashes later on. We call them these things as different. But you might hear about associative arrays. Dictionary, associative array, dictionaries. You'll hear all of these things. Dictionaries refer to key value stores. They're just a key and a value that are related to each other. So they're just a key and a value that are related. Let us take a look at. They're just a key and a value. How we declare. Let's take a look at. They're just a key and a value. How we declare. If you want, in your some code inside of your markdown files, 3 backticks. So that's right above the tab key. It's the same thing we use for the template backticks. Okay. So that's right above the tab key. It's the same thing we use for the template backticks. We can, in the same way that we could say, name equals, in the same way that we const child equals Alice, we can instantiate an object in the same way. There's no real magic to it. It's just, we can instantiate an object in the same way that we could say, like, we have a new array. It's just, we can instantiate an object in the same way that we can declare a new object. We have a new array. Okay. It's just, this is what we call an object literal. It's, we are literally writing out the object. We're literally creating it. We can go in right now and start adding key value pairs inside of this creating it. We can go in right now and so it might have. I don't want to go with name. What's a key and a value that an object might have? Just any. I don't want to go with name. What's a key and a value that an object might have? And we'll go with the American spelling so you don't get confused when it comes time for CSS. And we'll go with the American spelling always so you don't get confused when it comes time for CSS. So always with the, it could have a color in there. Awesome. So is this going to work? It could have a color in there. Awesome. If I put a semicolon in there, probably not. Let's find out here. Thank you. Awesome. If I put a semicolon in there, probably not. Objects.js. Thank you. Okay, here we are. So we're in here. Let's grab my object. Okay, here we paste it in here. So we're in here. Let's grab. Let's console log. Okay, my object. Okay. Node console objects. Okay. My object. Color red. Okay. Cool. Node console. What if we throw that semicolon back in here? Oh, color red. VS Code. Cool. It's trying to tell us something. What if we throw that semicolon back in here? It says that comma VS Code was expected. What if we throw that semicolon? Don't worry about the TS. It's because I write in TypeScript, so my linter actually thinks I'm writing in TypeScript. Don't worry about the TS. That's where the TS comes from. Because I write in TypeScript, so my linter actually thinks I'm writing in TypeScript. Don't worry about the TS. No semicolons inside of that object. You can just say key, colon, no semicolons inside of that object. And it can be a string key, it can be a number, it can be a boolean, and it can be a string key, it could be a number, okay? It could be a boolean, it could be, and it can be a string null. It could be a number, okay? It could be a boolean, and it can be a string null. Okay, so this is very frequently used because it's really nice, simple syntax for structuring out an object. We can just go down here and just list key value pair, key value pair, key value pair, comma separate down here and just list key value pair, key value pair, key value pair, comma separate, and we just keep adding things to the object. Okay, and we just keep adding things to the object. Cool. Any questions about object literals to the object? Cool. Any questions about? Okay. So we have a couple different options to retrieve values. We have a couple different options to, if we have an array, we have a couple from an object, as we saw. If we have an array, how do we grab one of the elements of this array? We use the square bracket syntax, right? If we wanted to grab the second one, 0, 1, 2. If we wanted to grab the number 3, that's when we grab it, right? 0, 1, 2. So naively, that's when we grab it, right? Why don't we try that? Naively, that's when we grab it, right? Why don't we try that? Naively, let's get this set up so that we can experiment. Why don't we try? Okay. So it's trying to tell us something here. An element access expression should take an argument. So it's trying to tell us something here. An element access expression should take an argument. Possibly confusing. Did you know that if you hover over the squiggle, it'll tell you what's actually the problem? Possibly confusing. Did you know that if you hover over the squiggle, it'll tell you what's actually the problem? Does anyone want to take a stab? And what JavaScript is trying to tell us? Want to take a stab? An element access expression should take an argument. What's an argument? Access expression should take an argument. It's a parameter. It's a parameter to a function, right? So it's saying that we can't just say, just like our at square brackets didn't make any sense, right? It needed something in here, right? At square brackets, what did we put in here? Sense, right? It needed something. The index value, right? We put in a 1 or 2, something like that, right? It needed something. So, right? We probably need to do the same thing in here, something like that, right? What happens if we put in right? We probably need to do the same thing in here, something like that, right? What happens if we put in right? We probably need to do undefined here, something like that. Okay, not exactly what we were looking for. The key. Okay, not exactly. So how do I get back? Let's say I want to grab color out of my object. So how do I get back? Let's say I something like this color out of my object. Awesome. Let's run this. Something like another error out of my object. Awesome. Let's run this. All right. Something like this. What is this error trying to tell us? Awesome. Let's run this. All right. Color is not defined. That's right. And I apologize for the bright green. I think that I live in the Matrix. That's right. And I apologize for my console bright green. You'll weeks from now you'll be like, yeah, it's always green. My console is. Cool. Color is not defined. Yeah, so errored out right here. You see the caret, and it errored out right there. At character 22 on line 6. See the caret? If we count it out right there. At character 22 on line 6. Why is it objecting to this? Count it out right there. At character 22 on line 6. Why is it objecting to this? Because I'm trying to treat it like a variable. Exactly. There's nothing in memory. JavaScript went, okay, you called this like it's a variable, so I'm going to look in memory, and I'm going to look for a variable called color, and I'm going to retrieve its value because that's how I work. And so it went out and it said color, and it went outside of here, it went all the way up as far as you could go, and it couldn't find a color variable, so it did the only thing it could do. It threw a reference error. It couldn't find a color variable. So it's important to note that it threw a reference error. This always needs to be a string. So it's important to put it inside of square brackets. It needs to be a string or something that evaluates to a string. It needs to be a string or something that evaluates. So we get back to null, which is what we thought for color because it was null. Let me change that to which is what there for color because and we get back. We change that to okay. So what was I saying about that? It has to evaluate to a string. What was I saying about that? It has to evaluate to a string. What was I saying about that? It has to evaluate to a string. So now when it looks up color in memory, it's going to actually find a value, and it's going to put that into here, and it's going to say inside of my object find a value. And it's going to. By the way, has anyone ever found this helpful where you can drag some characters around? Has anyone ever done that purposefully? I see a nodding head.
characters.
You actually did it purposefully? I've never done it purposefully. I always do it by accident.
You actually did it purposefully?
Okay, cool. So let's see if this works as we expect, and we get back blue.
Okay,
Neat.
Cool. So let's see if this works as we expect.
Remember, use square brackets. It always has to be a string.
Remember,
okay? Because it's going to try and look inside of here, looking for a string, and it's going to try and match
because
against
it's going to
those
try
keys.
and look inside of here, looking for a string.
Cool.
And it's gonna try
So
and match against those keys.
so far so good.
Looking for a string.
Now let's touch on something that we haven't really played with before.
Now let's touch on something that we haven't really played with before.
What's this going to do?
Now let's touch on something that we haven't
Ignoring all the rest of this,
What's this?
what are these two lines of code going to do?
Touch on something that we haven't
Ignoring all the rest
Sorry?
of this,
What's this
what are
gonna
these
do?
two lines of code going to do? Okay, so we set up
Ignoring all the rest
number
of this, what are these
as
lines
we
of
said
code
it was a constant.
Okay, so we set
Constant
up
means unchanging, right?
number,
And then we tried to
we
reassign
said
it.
it was a constant. Okay, so we set
Constant
up
means unchanging, right?
number,
And then we tried to
we said
reassign it.
it was a constant.
Assignment to a constant variable.
Constant means unchanging, right?
Okay? We were not able to
assignment to a constant
change that
variable.
value. We said when we declared it,
We were not able
this is going to be
assignment to a constant
change
variable.
a constant.
value. We said when we
right?
declared it,
And JavaScript is actually saying, like, look, you can't reassign this. And by the way, my rule of thumb for const versus let,
you can't
use
reassign
const
right.
everywhere
And by the way,
until
my
you get
rule
one
of
of
thumb
these.
for const versus let,
And then change that
use
variable
const
to a let
everywhere.
because you actually
By the way,
reassigned
you get one
it.
of
You'll
these.
probably find most of the time you
And
don't
then change
reassign
that
variables
variable to a
and
let
you'll just
because you
use
actually
const,
reassigned it.
like
You'll probably
99%
find
of
most of
the
the time you
And
don't
then
reassign
change that
variables
variable
to a let.
and you'll just
Cool.
use const,
So,
like 99% of the
all right,
time.
in light of that,
Cool. Why don't we explore
all right, in
how
light of
you
that,
set the value?
Why don't
If
we
this is how we
explore-
would read a value,
all right, in
how
light of
you
that,
my
set the
object
value.
square brackets
If this is
at
how we
the
would
name of the
read a
key.
value, all right, in light of that,
How do you think
my
we'd
object
set the
square
value?
brackets If this is
at
how we
the
would
name of the
read a
key?
value, all right, in how you
We'd
think
obviously
we'd
need to
set
make
the
reference
value?
to the object, right?
Value, all right, in how you-
Presumably
We'd obviously need to make reference
at
to
some
the object,
key,
right?
right?
Presumably
Presumably
need to make reference
at
to
some
the object,
key,
right?
right?
Presumably.
So let's go back to console logging.
Presumably.
My object.
So
Okay,
let's go
so
back
up
to
here,
console
I
logging.
declared my object as a constant.
My object. So
Okay.
Okay.
Now I'm going to go
declared my
inside
object as a constant
and change the color of red.
Okay.
Now I'm going to go inside.
Object as a constant.
Are we going to see
and
this
change the
error
color
again?
of red? Okay. Now I'm
No.
going to
Wow.
go inside.
Was it the way
Are we
that I
gonna see
asked,
this
or
error
you actually know?
again? Now I'm
No.
going to
Wow.
go inside.
Was it the way
Are we
that I
gonna see
asked,
this
or
error
you actually know?
again? Now I'm
No.
going to
Wow.
go inside.
Was it the way that I
Are we gonna see
asked,
this
or
error
you actually know?
Now I'm
No.
going to
Wow.
go inside.
Was it the way that I asked,
Right.
or you actually know?
No.
Wow. So you're saying that? Okay. So let's walk through that again.
you're
It's
saying that-
going into a property.
So let's walk
And
through that again.
it's updating the property.
you're
It's
saying that-
going
like
into
the
a
key,
property. It's
so let's
changing
walk-
out this
and,
value here.
it's updating the property.
Okay.
You're saying going
And
into a
that's
key,
why when
it's
we console
changing out
log
this value here.
this one,
updating the
we
property.
get,
Okay.
and
that's why
that
when
it's
we
not
console
actually
log
blue.
value here,
This one,
updating
it's
the
now
property.
red. Okay.
And that's why
That
when
it's
we
not
console
actually
log
blue.
value
Is that confusing to anybody?
It's now red.
But what's going on here?
And that's why
That
when
it's
we
not
console
actually
log
blue.
value,
Is that confusing to anybody?
It's now red.
But what's going on?
Okay.
We weren't able to do that with
Is that confusing to anybody?
our primitive values, right? We tried to reassign, and it said,
confusing to anybody?
our primitive
If you want to see the
values,
same
right?
error,
We tried to reassign, and it said,
our primitive
if you want to see the
values,
same
right?
error,
we tried to reassign,
and it said,
our
we're only going to see that error with objects if we do this level of reassignment. But other than that, we are free to edit any of these values inside. But other than that, it's only if we try and replace it with a whole new object. We could even delete all of the keys that are inside of this object, which we won't talk about today, and create all new ones. And JavaScript has no problem with that because it's making reference to the object itself, not the things that are inside of the object. Because you'll notice that we have to drill in further to get to those objects.
because you'll notice that
And
we
in
have
case
to
you're
drill
wondering,
in.
yes, primitives stored inside of an object are just as immutable as primitives
And in
stored
case you're
outside of an
wondering,
object.
yes,
If you try to do something like my dot color or at color dot to uppercase or something like that, it's not actually going to change what's inside of the object.
try to do to uppercase or something like
Just
that.
like it didn't change the primitive string was outside of the object. Awesome. So now we have the ability to edit keys. Awesome. Okay. So now we have the ability to edit keys. What about if we want to create a whole new key? What about if we want to create a whwhole new key? So the ability to edit keys. What about if we want to create a whole new key? So the ability to edit keys. What about if we want to... Is this syntax going to work? So the ability to edit keys. What about if we want... Is this syntax going to work? Neat, right? So we can actually, it's the exact same syntax to read the value. So we can actually, as it is to set the value. It's the exact same syntax. You just say to read the object. So at as it is to this key, you just equals this new value. The object at as it is to this key. So we can actually set values after the fact. We can change them. So we can create whole new keys values on the object, as evidenced by a whole new key. We can create whole new keys, and there it is. And that's perfectly valid JavaScript. You can actually create all of your objects where you just do valid JavaScript. You can actually I just need an object, and then I'm going to specify all of the keys after the fact. I just need an object, and in fact, and then I'm going to specify this code doesn't break either. It's just missing, and in fact, that initial key that we had on the object literal. It's just missing. You can declare an empty object, that initial key that we had, and then add things to it. It's just missing. You can declare an empty object, that initial key, and then as we saw earlier, you can declare an empty object. If you try to, and as we saw grab something that, if you try to, and as we saw grab something that, if you try to grab something that doesn't exist from an object, you'll get undefined. If you try to grab something that doesn't exist, that's important to keep in mind. Undefined is that if you try to access something, important to keep in mind, it comes back as undefined. You'll see these if you try to access errors a lot around undefined dot something is not a method and things like that. So remember that if you try to access a key that does not exist, just like an array when we tried to access an index that didn't exist, we got back undefined. If you try to access a prop that doesn't exist, you'll get back undefined. It's not going to error out. Your code will continue to run. It doesn't exist. It's just going to come back as undefined. It's not going to error out. Your code will continue to run. It doesn't exist. It's just all right. So we can add things in. There is another syntax that developers kind of lean towards because it's a little easier to read, and that is developers kind of lean towards because it's a little easier notation. So you've probably seen this where we could do myobj.color. So you've probably seen this where we could do my if we console log. So you've probably seen my object. We should see if we console log. So you've probably seen my object. That color is now orange. Okay. I was able to access that. This is just different syntax. It can be confusing. This is just if you find the square bracket syntax works for you and you can wrap your head around that, that's great. This is actually just a shorthand for this, and there's things that square brackets can do that dot notation cannot. There's things that square brackets can do, so that dot notation cannot. You can wrap your head around that, and that works for you. Feel free to continue using that until you get comfortable with seeing dot notation everywhere. Until you get comfortable with. The other thing is, this is showing us that whatever's to the left of that must be an object because dot syntax only works on objects. Whatever's to the left. So interestingly, because dot syntax. What does that tell us about this? Whatever's to the left. So interestingly, console is an object because dot syntax. What does that tell us about this? Whatever's to the left. So console log. Console. Console. Hey, there's console.assert. Remember that from a couple days ago? Log, debug, info, warn, error. That from a couple days ago? Log. It's an object. Info, warn, error. That from a couple days ago? So it's an object. Dot syntax. You can make a reference to any property in there. And remember, dot syntax. You can make a reference to any property in there. We can also make reference to things that don't exist. Dot syntax. Oh, that's not what I wanted. Property in there. We can also make reference to things that don't exist. Dot syntax. Oh, that's not what I wanted. Property in there. We can also and we come back as undefined. Okay? That's what we'll get back when we're trying to access something that then we come back as undefined. Okay? My rule of thumb for when to use dot notation versus square bracket notation is if you know the property name beforehand, if you explicitly know it at the moment that your code is being written, like we know that myobj has a color property, then just use the dot notation because you already know it, and you can can just say dot notation. But let's say this is coming through in a variable. But like this. This is coming through in a variable. Let's do something like this is coming through in a variable. Let's do something like another key equals color, so we'll say my obj at equals color, so we'll say another key equals red, so we'll say, and if we run this, we'll see color orange, whole new key. Where are we? My obj at run this. Another key equals color. That's right. I should change this to another key equals is awake. There we go. She changed this to another key. So we were able to set that up. There we go. We were able to programmatically move this into here. So we said whatever this is awake. Programmatically move this into here. Interpret it into here. Then say my obj. So it's the equivalent of into here. Then say my obj, so it's the equivalent of, which doesn't make a terrific amount of sense, but, you know, depending on what time of the morning you ask me if I'm awake or not, I might answer red at some point. You know, depending on what time of the morning you ask me if I'm awake or not, I might answer red is equivalent to this. After JavaScript figures out what's being stored inside that variable. Okay? But JavaScript figures when I said there's things you can do with square brackets that you can't do with dot notation. But JavaScript figures when I said there's things this is the trap that people fall into with dot notation is you try to use the dot notation with a variable name. You try to use the dot notation with a variable name. That didn't work as we expected, right? It actually didn't use this at all, right? It actually simply created a whole new key on my object called another key. It didn't actually look up the variable key on my object called another key. Okay? This happens a lot, especially today, that you try to access a variable with dot notation, especially today. It doesn't work this way. If you have a variable with dot notation, especially today, square bracket, it doesn't work this way. If you explicitly know the name of the key, square bracket, it doesn't work call with dot. So if you don't know the name of the key, if it's in a variable or you're iterating through a loop or something, if you don't know the name of the key, use square brackets. If it's in a variable or you're iterating through a loop or something, and it's the same syntax for retrieving a value as it is for setting a value. Same syntax for retrieving a value as it is for setting a value. Same syntax for retrieving a value as it is for setting a value. Same syntax for retrieving a value as it is for setting a value. Yep. Retrieving a value as it is for setting a value. Yep. That's right. Yes. Yep. That's right. Yes. Yep. For here? Yes. Yes. For here? Yes. So you're thinking something like this? For here? Yes. Okay. So you're thinking something like this? All right. Let's. For here? Yes. Okay. So you're thinking something like this? All right. Let's. For here? Yes. Okay. So you're thinking something like this? Well, inside of this object, that exists. Outside of that object, JavaScript has no idea what you're talking about. That exists. So if you wanted to make reference to it like that, so you'd have to say dot to make reference to it. Okay. Because otherwise JavaScript has no idea what you're talking about. It doesn't know where whole new key is. Because otherwise JavaScript has no idea what you're talking about. We see that it totally works. Whole new key and event this now. We see that it, okay, totally works. Whole new key. So that was okay. Objects 101. So in our last 22 minutes, let's take a quick look at what happens when we pass these things to a function. Let's take a quick look. So at what happens when we pass, we need these things to a function. Actually, so what happens when we pass, we need things to a function. Let's do this online. Okay, have you seen Python Tutor? Yes. Has anybody shown you Python Tutor? Okay, have you seen Python Tutor? So it is a. Has anybody shown you Python Tutor? Pretty powerful thing that allows us to look at our code literally one line at a time. So if we do something like literally one line rule equals true, num equals 27 equals true, and obj equals 27 equals true, and obj equals 27. So we're creating three things. Nope. I'm hardwired to hit Command S every single time I finish typing a line of code. I'm hardwired to
we're setting up
Command S
3
every single time
spots in
I
memory,
and we're assigning them 3 different values.
setting up 3
So let's watch
spots in
this
memory,
execute.
and we're assigning them
Go down to
3
visualize
different
execution.
values. We're setting up 3
So let's
cool.
watch this
Okay,
execute.
so on this side,
we can see our JavaScript code, and we can see the line of code that's going to be executed, and very shortly the line of code that was executed. Down here we can see how many steps our code is going to take. And on the right-hand side, we'll see our output, what gets put into memory, and what we would console log if we console log output. So let's see the first line of code. And what we would console log. Cool. So there's a global variable now because we're in the top level of this file called global variable now because we're in the and its value is true. Called neat. Okay. And its value is true. Now there's another global variable called num, and its value is 27. And note that it is literally pointing bool refers to true, and num refers to 27. Right? We could all agree that if we said console log num, we'd see 27. Right? Let's watch what happens when we assign an object. We'd see to a spot in memory. Right? Let's watch what happens when we assign an object. It didn't do the same thing that we saw before. We didn't get this here into here. Do the same thing that we saw before. Instead, what's stored in object is what we call a reference. Instead, it's this line here that gets stored in memory. Not we don't have direct access to this part of memory. We have to use it through this reference to memory. And that is a critical difference for if we want to say pass something to a function or reassign a variable. So now you can see why we were able to do something like see Command S. I'm just hardwired. Visualize the execution. Let's step through real quick, put those things into memory. So we have this reference now, and that's why we can reassign a constant reference now. Because we're actually changing what we're not changing what this points to. Because we're actually changing we're not changing what this points to. Name is Alice, and next name is now Bob. We haven't actually changed the object itself. We have this line. We haven't actually didn't change object itself. We still had that pointer to the same thing, the same object. We still had this curly brace to this curly brace, the same object, but we didn't actually change the value in here. Whereas if we said, okay, bool is now false, we would get an error because it would say you're trying to reassign to a constant. Bool is now false, but this pointer here is the reason why we can change the values inside of an object or an array, is the reason why and not throw any kind of errors, not run into that immutability thing. Is the reason why and not throw any kind of errors, not run into that immutability thing. It is the fact that obj is the reference. But we're saying we are never going, by saying const obj, all we're saying is not that we're never going to change the object, because we can and we probably will. It's that we're not going to change the reference. We're not going to say obj equals now this different object. We're not going to change that. We're going to change the parts inside of the object or inside of the array. We're not going to change that. We're going to change the parts inside of the object. Now let's go back and we'll see what happens when we have something like name equals Alice, and we'll see what happens. And then I'm going to do what will probably look like name equals Alice, and we'll see what happens. And then I'm going to do a destructive change. So it's going to take in a name, and then I'm going to do a destructive change. So it's going to take and it's going to say name equals Bob. So it's going to take and it's going to and then we'll console log name inside of the function, and then outside of the function, and then we're going to call change name inside of the function and pass in Alice. And then we're going to call change name, and then we're going to console log Alice name. Let's call this change name, and then we're going to console log Alice name. Let's call this change name, and then we're going to console log name. Let's call this Command S. Okay, so very quickly here, we set up a constant, a name of Alice. So very quickly here, we set up a function that will change a name. It will take in a name, change it to something else. In this case, it will change it to Bob. It will take in a name. Then we'll console log. Change it to something else. We invoke that function down here, and we pass in our name. Then we'll console log. And then we're going to console log the function down here, and we pass in. So does everyone have a guess? And then we're going to head about what this is going to print. So does everyone have a guess? And then we're going to head about what this is going to print. So does everyone have a guess? And then we're going to head about what this is going to print.
does everyone have a guess?
Okay, so
About what this is going to print. So does everyone have a guess?
okay, awesome.
About what this is going to print. So does everyone have a guess?
Okay, awesome. Okay, let's see how this actually sets up. We're going to step through. First thing, should be no surprise. Note that we have this new box up here. It's smart enough to say, oh, you console log something. I'm going to give you an area to show that. Note that we have this new box up here. So it puts our name into memory. I'm going to give you an area to show that. Then it puts change name. And remember, it put that function on the object side. It puts change name. So it has put this entire function into memory. And we have a reference point to that. So it has put this entire function into memory. This will be important for tomorrow. Tomorrow is all about function to that. So it has put this entire function. Then the next line of code to run will be the actual invocation of this function. We're actually going to run this function. Then the next line of code step through will be the actual. So inside of this frame, inside of here, it was passed in name was Alice. Inside of this frame, inside of here, then we're going to step through. Now name is Bob, right? That makes sense. Name equals Bob. Then we're going to step through. Then we're going to console log inside name equals Bob. Then we're going to step through. Then we're going to console log inside return value. Incidentally, all functions have a return value. We didn't specify one, so we go back undefined. All functions have a return value. That's why we see this undefined here. But notice that Alice is still, that's why we see this undefined here, unchanged. But notice that we jump down to our last line of code, we console log, unchanged. Outside is Alice. We jump down to our last line of code, we console log, unchanged. We're not actually changing Alice, and the reason is because that primitives are what we call pass by value. So in other words, it's a copy of the value. So when it went into this function, yes, it's a copy of the value. So when it went into this function, yes, it's a copy of the value. So when it went into this function, yes, well, actually, technically, all of your arguments are declared on your behalf. Behind the scenes, JavaScript makes sure that this is something that's in memory for you. We created a name. JavaScript makes sure. But the point is, when we called down here, we didn't actually pass name into there. Notice I didn't say we're passing in name. I said we're passing in Alice. We're passing in because what JavaScript did is it copied the value from this name, the outside name, to this internal one. From inside. It just copied it. Primitives always get copied. So we call that pass by value. Okay? So you're not actually dealing with that value inside of the function here. You're dealing with that value. You're not dealing with this variable of the function inside of the function. You're dealing with that value. You're not dealing with this variable of the function inside of the function. Yes. You're not dealing with this variable of the function inside of the function. Well, let's find out. So the question was for the recording, what if you passed a function another function? So the question was, spoiler, that's another function. That's the topic of tomorrow's lecture. So what if we pass a function an object? That's the topic of tomorrow's lecture. So what if we pass a function an object? That's the topic of tomorrow's lecture. Yes. So let's find out what happens here. Okay, so this is going to take in, let's find out what happens. Some object, and I'm going to call, so this is going to take in obj, and then we're going to say, and I'm going to call obj.name, obj equals Bob, and then we're going to say, obj.name, obj equals Bob, and then we're going to say, and we're going to call change name, and pass in my, and we're going to call change name, object. Cool. And I remembered not to hit Command S, but my fingers hovered over the keys. Okay. Cool. So, and I remembered almost the same, but my fingers hovered. We were creating a point in memory, and we're storing a value in it. We were creating a point in. We have a function called change name that takes in an object. We have a function accesses the key on that object, changes it to Bob. Console logs that key on that object. Outside we have change name, pass in my object, and then outside we console log change name. What happens outside object? Okay, does everybody have an idea in their head about what we're going to see? Remember that before, okay, does everybody Alice didn't change, right? Yes. About what we're going to see. Remember that before, okay, does everybody Alice didn't change, right? Yes. About what we're going to see. Remember that before. Okay, so the thought is that because our function doesn't actually return anything, we're going to see the same thing as last time. The thought is that this is still going to be Alice when we console log. we're going to see the same. So let's step through. First thing we do is we created a spot in memory called myObj, and which is a reference to an object in memory which has a key value pair of name and Alice. Which is a reference to an object in memory which has once again we set up this change name function and put it into memory. And it is an object, so it ends up on the object side. And put it into memory. Then it is an object, so we invoke the function. But something weird happened. Remember before, down here it said name, but there were two names. There was a name up here that said Alice, and a name down here that said Alice. But there were two names. This time we didn't get that. And a name down here that said Alice. This time, obj, that got passed into here, and a name down here that said Alice is pointing to this object. That got passed into here. It's literally pointing directly to that same one. It's literally pointing. So we step through directly to that, and Alice changed to Bob. It's literally pointing. So we step through directly to this, and then we console log inside. Obj.name is Bob, and then we console log inside outside. Obj.name is Bob, also Bob, and then we console log inside outside. Let's watch that critical step. So when we passed the object into memory, into this function, when we didn't pass object, remember when I said primitives, you get a copy of it, right? They're passed by value. 1150. Remember when I said still tons of time. You get a copy just early, right? They're passed by value. 1150. They were passed by value. You get a copy of it, right? So even though we tried to change the value of name, we tried to reassign it, it didn't actually take outside of our code because we were playing with a copy. It'd be like I gave you a photocopy of something and you got coffee on it. You spilled coffee on it and then you're like, sorry, and I was like, whatever, it's just a copy of something. But if I said, this is my manuscript, it's the only copy in the world, I'm going to give it to you. That's how we're passing objects around. We actually pass the reference. It actually gets a copy of the reference. We actually pass to the object. So it can access that object just as easily as we could outside. Okay? And that's why we're able to change that object. Okay? So be careful about how your things are being passed in and whether you're doing some kind of reassignment, because arrays and objects and functions, anything that's not a primitive, you can change it. Okay? If you get your hands on it, you can change it. And it's because of this reference thing. It gets a copy of the reference that points to the same spot in memory. And if we were to say, does my obj equal obj, it would. And because it's referenced, it points to the exact same spot in memory. It would. And because it's referenced, it points to the exact same spot. It would. With the notes, I'll send out some of these so you can walk through them as well. And you can play with this. This is a great functionality for walking through your code, especially if you were doing something like loops, some kind of iteration, and you wanted to see what it looked like and what values were actually at whatever time. And this is, I know it's called Python Tutor, but they have a ton of different programming languages in there. I know it's called Python Tutor, but they have a ton of different programming languages. Primitives, we pass by value. It gets a copy. It doesn't actually change the outside. Primitives, we pass by objects, we pass by reference. They actually get a copy of the reference, which means that they can change the object. They actually get a copy. So think about these pointers, which means that they can when you're pointing to a complex data structure. So think about and bear in mind that you can absolutely change it either on purpose or by accident. You can change it. So keep in mind things like this. Are you actually just looking up a property on the object, or are you trying to set a property? Are you actually just so if you see that your data is changing, it's probably something like this, somewhere where you thought, but it's immutable, or I have a copy of it, something like this. Maybe you don't have a copy, maybe you have the real thing, or I have a copy of it, something like this. Maybe you don't have a copy, maybe we have 7 minutes left, we have one more thing that I wanted to touch on, which is, we talked about key value pairs, right? The key is a string, an object. We talked about key value. The value can be any valid key is a string thing in JavaScript, including the value can be any functions thing in JavaScript. So let's take a look at what this looks like. Functions very quickly. So let's take a look at we'll call this functions very quickly. There we go. Methods. We'll call this so very quickly. Functions inside of objects are referred to as methods of that object. Okay. So functions inside of objects are referred to as methods of that object. My object. And we're going to give this thing first name, colon syntax.
And we're going to give this
Alice.
thing referred to as methods of
A last name of
colon syntax. And we're going to give this
Neverland. For some reason, that's on there.
a last name of colon syntax. And we're going to give this
Neverland. For some
do
reason,
that.
that's on there.
A
I'm going to try
last
to connect to the
name
youth of today.
Neverland.
Does that register with anyone?
I'm going to try to connect
Okay.
to the
Yes.
youth
One nodding head. That's
today.
perfect. Awesome.
Does that register with anyone?
Okay.
Okay.
So
one
key
nodding
value
head,
pair.
that's
Key value pair.
Awesome. Does that register with anyone?
Okay. What if I wanted to
Key value
attach, let's say,
register with anyone?
a function
What
to
if I
this?
wanted to
Attach, and this function is going to console log a function
What
to
if I
this.
wanted to
Hello there.
attach,
And this function is going to console log a function to
What if I
this.
wanted to
Hello there.
attach,
And this function is going to console log a
function to this?
Is this valid syntax?
Hello there.
Is this going to throw?
This function is going to console
What do you think is going to happen here?
Is this valid syntax?
Hello there. Is this going to throw?
This function is going to console
What do you think is
Well,
going to happen here?
just
Just
right
right
now,
now. Let's take a look at it.
Throw.
Cool.
What do you think
Well,
is going to happen?
we
Just
get
right
our.
now.
We know it's an
Let's take a
object.
look
We've
at
got
it.
our curly braces here.
Cool.
We have a first name key, Allison.
We get our
last name.
We know it's an object.
Wonderland.
We've got our curly braces here.
And then we have
We have a
this
first name key, Allison.
Say
We get
hi.
our last name,
which is actually a
Wonderland.
function.
Got our curly braces here.
And then we have
We have a
this.
first
Cool.
name key, Allison.
Okay.
Say hi.
So
Last
what does that
name,
allow
which
us
is
to
actually
do?
a function. Got our curly braces here.
Well,
And then we have
presumably
this.
we could do something like
Okay. So what
my
does that allow us
obj
to do?
square bracket.
Well,
Presumably we could do something like
So
say
what
hi.
does that allow us to do?
Square bracket.
Well,
Presumably we could do something like.
Okay.
What do you
Say
think
hi.
that gives us back? Square bracket.
Well,
Presumably we could do something like.
Okay.
What do you
Say
think
hi.
that gives us back? And
Square bracket.
cool. Error. I like that.
What do you think that gives us back?
Everybody else have an idea in their head of what's going to happen?
Error. I like that.
We're going to console log the object, and then something's
else
going to
have an
happen.
idea in their head of what's
Cool.
going to happen?
Error.
I like that.
We're going to console log the object, and then something's going to happen.
We
We were just able to get
We're gonna
this.
console log the object, and then
We just said give me back,
we
say
were
hi,
just
and
able
console log
to-
it. And it said get this. Sure.
console log the
By the way, if you
We
want
just
to
said give me
actually
back, say
see
hi,
what's
and console
inside
log it.
of,
and it said get this.
sure.
By the way, if you
A
want to
function,
actually see
you can call
what's
toString on it,
inside of- and it said
and it'll actually console log
By
the
way,
entire
if you want
function
to actually
to your
see what's
console.
inside
So
of
if you want to see what's actually inside of it, just call
console
toString on
log
it.
the entire
Okay,
function.
but at any rate,
So if
you wanna see
what's actually inside
every
of it, just call
single
toString
other
on the entire
property,
function.
but at any rate, we were able
So if you
to
wanna see what's actually
name the
inside of it,
function
just call toString
other
on the
and then
property.
name its prop
But at any rate,
and
we
get
were
back
able
this.
to
Okay,
name
so
the function,
what do we do with
and then
functions?
name its prop.
Rarely
and
do
get
we
back
console
this.
log them or call
Okay, so
toString on them. What do we do with functions?
Name its prop.
Rarely do we call them or call toString on them. What do we do with functions?
Name its prop.
So if let me get rid of this, the console log around it because it's now doing its own console
Let me get rid
logging.
of this.
The console log around
My
it
obj
because it's
at
now
say hi
doing its own console
invoke
logging.
it.
The console log around
My
it
obj
because it's
at
now
say hi
doing its own console
invoke
logging.
it.
The console
Hello
log
there.
around it
My obj
because it's
at
now
say hi
doing its own
cool,
console
right?
logging.
It's
Sorry.
hello there.
At say hi doing its own
Cool,
console
right?
logging.
It's
sorry.
hello there.
At say hi.
Oh,
right?
like I said, if you know the name of it,
Like
it's
I
usually
said,
preferable to
if you
use the
know
dot
the
notation.
name of it,
But like I said, whatever works for you. If you explicitly know the name of it, which we do here, we can just say dot say hi. These two lines are equivalent. Let me get rid of this so it's not cluttering it up, and we should see hello there, hello there.
Let me get rid of this.
These two lines are exactly equivalent, and we should see hello there, hello there. They do the same thing. They look inside the object for a key called say hi.
They do the same thing.
They get it back and then they invoke it. Okay? Just like before when we wrote that big long thing with the split and the join and the two uppercase and all that jazz.
Just like before when we wrote that big long thing with the
We can access it even if it was more deeply nested inside. Maybe we had an object inside of here that had objects inside of it. Then we might have like object inside of
dot
here that had
funcs,
objects inside
dot
of it.
say hi or something like that. Like let's say we wrap this dot funcs inside of an object or something like that.
And resist the urge to say
object inside
object.
object.
Resist the urge to say
Because Inception was not actually about a dream within a dream. It was about implanting an idea.
because Inception was
that's
not
just my
actually
little
about a dream within a dream.
diatribe on that.
implanting an
Okay,
idea.
so check this out.
Because Inception was
That's
not
just my
actually
little.
about a dream
Now we
within a
have
dream.
okay, a key
So check
called
this out.
funcs, which is itself an object with a function inside of it called say hi, an object. So if we wanted to make these two equivalent,
say hi. An object.
we go into
So
funcs.
if we wanted to make these two,
Then we go into say hi,
equivalent,
and then we invoke it. We go into
So
funcs,
if we wanted
and we
to
get the
make
exact
these
same
two,
thing.
then we go into say hi,
and then we
okay?
invoke it.
We go into
So,
funcs, and we get the
they could
exact
be
same
as
thing.
deeply nested
as you want. You're going to deal with the music library today, which is great. You'll have objects inside of objects with arrays inside of those, and you're going to get a ton of experience with this. Like anything else in life, it's just practice. The more you see it, the more familiar you become with it. The more you do it, the more you get muscle memory to just type things like this out. The more times you access properties in an object, the more comfortable you'll get. Okay, it's just time that you have to take. But what's really interesting, let's take this back to how we had it before, just so everything's on the same level. Let's take this back to how we had it before, just so everything's on the same level. Okay, so we're back to here. We're back to this is still working. Okay, so we're back to here. Let's make sure that my refactor works. Yes, code is still running. We still see hello there. Let's make sure. Why don't we add another one called code is still running. We still see hello there. Full name. Why don't we add another one? That'd be kind of interesting, right? Oh, and by the way, yes, absolutely. These can also take parameters when you call them if you needed to. Yes, absolutely. You can do anything that you can do with a normal function. It's still a normal function. It's just attached to the object. You can even do something crazy like still a normal function. It's just attached to the object. You can even do something crazy like still a normal function. It's just attached to the object. You can even do something crazy like still a normal function. It's just you could even do something nutty like that. Like grab that function out of the object and then invoke it on your own if you want. You'll get more into this tomorrow. Okay, tomorrow is all about functions on your own if you want. So we won't dive too far into that. Tomorrow is all about functions. We want to say our full name. So we won't dive to this. So I want to be able to console log. We want to say our full name. And I want to be able to get. So I want to be able to console first name. We want to say our full name. And I want to be able to get and last name. We want this to console log. And I want to be able to this and last name. Allison this to console and Wonderland to the console. This okay. And last name. Allison this to Wonderland to the console. Is this going to work? Allison this to Wonderland to the console. Any thoughts as to why it's not going to work? Any thoughts as to why it's not going to work? Exactly right. So let's run this just so we can see the error. First name is not defined, just like anywhere else. So let's run this. It looked and it said, first name is where's first name? Just like anywhere else. I want you to try to interpolate that here. I want to hear write this to the console. The programmer explicitly asked me to write this to the console. But then it said first name. It looked inside of this object. But then it said nope. There was nothing. There was nothing like this. First name equals Bob. Something like this. There was nothing like that. It looked through here. It said I don't know. Then it looked into the global scope, the whole of the file, and it said, hey, first name. Is there a first name anywhere? Nope. Okay, I'm just going to throw an error. Hey, first name. So first name anywhere? Outside. Okay, I'm just going to throw an error. Hey, first name. So we can say outside first name, right? I'm just going to throw an error. We've already used this syntax. We could either do this or this. We've already used this syntax. So should we try that in here? This. We've already used this syntax. So should we try that? You never want to try anything. It's just, is it the way that I phrase it? It's got to be the way that I phrase it. You never want to try anything. It's just, is it the way that did I say the answer 100 times? It's got to be the way that I phrase it. You never want to try anything. It's just, is it the way that did I say the answer 100 times? It's got to be the way that I phrase it. You never want to try anything. Whoa. Is it the way did I say the answer? Surprisingly, that actually worked because it went out to the scope and it found my option. And it was able to use it inside of here. But we actually have a different syntax, so that actually surprised me that worked. But we actually have a different syntax, but it did actually work. But we actually have a different syntax for making reference to other keys inside of an object from that object. And it's a special keyword that we use to make reference to the object from that object. And it's a special keyword that we use to make reference called this. And it's a special keyword that we use to make reference inside of an object. This refers to the object itself. So we should see no difference between when we called it my object itself and when we called it no difference between when we called it my object itself and when we called it this is it's a very broad topic. This is something that's probably going to take weeks if not months to fully come to terms with. This is something that's probably going to take when you're inside of a method to fully inside of an object, you can make reference to the object that you're in with this and get back to this reference, and we can feel free to use with this. The dot notation as well if you want. And we can feel free to use with this. The dot notation as well. How are we doing for time? 12:03. The mentors are circling like hungry sharks. How are we doing for time? 12:03. I don't want to keep you from Jeremy. Like hungry sharks. Any questions? Anything come to light? Is this keep you from Jeremy? Like hungry sharks. Is it too much? Any questions? Anything come to light? Is this keep you from Jeremy? Is it too much? Any questions? Anything come to light? Is this keep you from Jeremy? Any questions? Anything before I let you go? If you think of anything, I mentor all afternoon. Otherwise, hit me up on Slack or ask any of the other mentors. Hit request assistance and have an in-depth conversation. Okay? Thank you for your time. Of the other mentors. Hit request assistance and have an in-depth conversation. Okay? Thank you for your time.